All right. So as I was saying, we're gonna be doing a assembly drawing question. Here we have the question that says we should not spend more than 2 hours on this section. Normally the CXC question, we are given two CXC questions, the assembly drawing and the sketch and design, which should take about 30 minutes. So the entire paper will be about 2 hours 40 minutes. There is an additional 10 minutes to read through the paper. So this question, we should spend roughly 2 hours in order to complete the drawing. So for this question, it says that figure 2 on the enclosed sheet shows the first angle orthographic projection details of the part that make up the movable arm assembly. So this is the diagram of the movable arm assembly. So we have part 1, which is called the arm, or item 1, which is called the arm. So we get two views for that. Item 2 is called the base. We also have two views for that. Item 3 is the fulcrum pin. And item 4, it's a hexagonal nut. It says M24 hexagonal nut. So that's the size, that's the diameter. The 24 is the diameter, the internal diameter of the nut. And the M means that it's a metric nut. So let's go back to the statement here. It says, in assembly, the arm, which is part 1, is mounted into the base, part 2. The fulcrum pin, which is part 3, is then inserted through the base and the arm and secured with a M24 nut, which is part 4. The arm can then be rotated through 90 degrees between point B and O. This is point B here, and this is point O. So in other words, this arm, this movable arm, can move from a vertical position to a horizontal position. It can move through this 90-degree angle here. All right, so what are we supposed to be drawing? It says draw full size in either first or third angle orthographic projection the following views of the assembly when the arm is at rest at point O. So what they want us to do is to draw this arm in a flat position, in a horizontal position across here. So currently it's set vertically. They want us to draw it horizontally, right? With this part here in the middle and the arm hanging off to the side here. So we're gonna be drawing the plan view showing all hidden details. And that's a full sectional front elevation on cutting plane XX. This is the cutting plane line here, X, straight across the middle, X. So this is XX. So the cutting plane simply means that we're gonna cut the plan view in two. So it's as if you're sawing this object in two when it is fitted together, and then showing on the front view what that looks like. So after that, you're gonna put on 6 main dimensions to include a length, a diameter, a radius, and a metric screw thread specification. And then part C is to print the title, which is movable arm assembly. That's the title. And the scale used. The scale used is full size. See here? Or if you want to write the word, the number 1 to 1. And then we're going to show the projection method by symbol. That is simply saying draw the symbol used either the first angle or the third angle symbol, whichever one we use to draw the diagrams, uh, and put it together. So currently this drawing is done in first angle projection. So this is saying that the plan is at the bottom. This is the plan view. This is the front view. We get two views for the arm here, and one view for the fulcrum pin, and one view for the hexagonal nut. All right. So in putting this together, we're gonna look how we put this thing together in AutoCAD. In addition, it says all fillet radii are 3 millimeters. So we have some small radius. For example, we have one right here, this small curve here, and there's another one right here, and they have a few more on the drawing at some of these corners here. All of these small radius, they are 3 millimeters, right? So when we draw this now, we're going to cut the object in two along the cutting plane line XX. So we're going to now move over to AutoCAD and see what the finished product would look like. So let's move over to AutoCAD. All right, so let me just open that window. Let me show that window. So here we have basically some of the items drawn already. This is the item 2, which is the base. So based on the figure, by the way, this figure is in Google Classroom already on the assembly drawing. It's called the movable arm assembly. So you can look for that afterwards. So this is one view, the front view for the um, the base. And here we have two views for the arm, right? So when we fit this together, basically this piece here should fit horizontally on this. But since it was drawn like this, what basically I recommend that students just draw the pieces as they are on the paper, and then we move them afterwards. So for example, we're gonna put the arm in a horizontal position. So I'm just gonna move it from here and then rotate it. Just let me move it from here and then rotate it at 90 degrees. So I'm gonna rotate this object. Let down here be the center rotation. I want object to be like this, right? And then I'm gonna now move it from here and put it, hold it like at the center here and place it on the center here. So this is it now, where the arm is horizontal. According to the question, it says that we should draw this piece so that it rests on O, and O was right here and B was in this area up here, so the arm is flat. So basically we have two pieces here. Now for the fulcrum pin, the fulcrum pin will be set in such a way that it is as if it is moving away from me going into the screen, right? So only the head of the pin I will be able to see right here. So I would draw a circle to represent the fulcrum pin. The size of that pin, let me see what that was again. The size of the fulcrum pin was 45. So I'm gonna have a circle. I'm gonna have a circle here, 45. Let me see what that would look like. The diameter, so that would be center diameter from the center here, diameter 45. So that is it. This circle here represent the fulcrum pin. So just let me change the color so that we can establish it. Let me get a new color for that one. Get a new color. Just call it circle. Or no, let me call it pin. And change that color to, let's use this, number 13. So this is the pin head. In that color 13. So that represents the pin head. We cannot see anything else from the pin head looking in the front view direction, because everything is behind the head of the pin, which is the pin. The head of the pin is the biggest part of the pin. We cannot see the rest of the pin, and we cannot see the nut that is on the other side of the drawing, right? So that is hidden. So the only thing that we need to do to complete this, the front view, is to put in the hatch lines. That was done over here already for the hatch line. So it would look something like this. The hatch is in one direction for one part. So since it is two parts, you have the base beam section and the pin and the arm section in a different direction. So we section them in a different direction because we have two items. So two items, if it is two or more, well, if it is one item, we have one direction on it. If it is a separate item, then the pattern must be different for the second item, right? So as many items as we're going to be sectioning, it's a different pattern for the items. So since it is only two items, then we have two patterns. We do not section pins and bolts and nuts and washers and stuff like that. There is a list in Google Classroom under sectional views. There is a slide in that presentation that says what sections or hatch lines should be omitted from. So you can look at that to see what objects are not normally sectioned, right? And you might be wondering why this area on the left and the right, they are not sectioned either. And they are a part of the base. That is simply because this is a web and this is another web. So it's like two supporting columns in a sense, or two supporting wedge that holds the rest of it in place. So webs are not sectioned, so we leave it like that, not section, right? So this would represent the front view of the drawing, sectional front elevation, right? The question also asks us to draw the plan view. So we would do the plan. Well, I did this at an earlier date, completed plan view. So what I recommend that students do is to draw the individual pieces and then move them in place. It is easier that way. But this one was done with everything in place. No movement was taken, has taken place after, right? So what you can do is to draw, for example, the nut and put it in place. So here is a nut over here. Here is a nut that was drawn. So what we would do is to move the nut in place and place it right here. So the pin goes straight across here. right? So the base is here already. You could draw the pin separately, then put it in, draw the arm, put it in place, draw the nut, put it in place. So this is the plan view. We are looking down on the object. And the question says that we should put in all hidden details. So everything that we cannot see by looking from the top, we still have to put them in as broken lines. So the cyan or this pale blue color here represents the, the hidden details. So if you notice, there's a wedge on each side, four webs coming together to support the base, the centerpiece for the base, right? So looking from above, we cannot see those areas, but we know they are there. So it is in a hidden detail. What else? Part B asks us to put in 6 main dimensions. A length, they ask us for a radius. This one here is R14, R19. They ask us for a diameter. Here's a diameter up here, diameter 32. So for those, we would click right here beside linear for the diameter. For the radius, this one is used, this one here, diameter. For a linear measurement, a straight line measurement, we use linear. If we want an angular measurement or to measure an angle, then we use angular. If we want an aligned measurement, this one is normally used with the three-dimensional objects. We did some isometric, then this is the one that would use. So those are the major ones, right? So they ask us to put on radius, diameter, a length, and a metric screw thread specification. So for the metric screw thread specification here is one that applies, it really applies to the nut. This arrow should be on the nut. So let me see if that can be moved from here to here, right? So it applies to the nut. M means metric. So 6C is only going to ask us to draw metric objects, right? And the 24 is the diameter from side to side. That's the hole passing through the nut. M24. So it's a metric nut and the diameter is 22. So how do we write this M24? How do we write it? There is a little icon here below the dimension one. We can click on the arrow down here, down arrow, and it says leader. If you click on leader, you click on the object, for example, like this, then we are able now to type the measurement. Let's say M24, enter, escape, right? So we have it like that, right? So that's how you would write the measurement there in this case. So it's the little icon here that says leader, right? And you write, you click where it should be from, and then at the end now you're gonna write your particular measurement, right? So we have it there already. So let me take this out. All right, so they ask us for 6 main dimensions. So make sure you have the 4 that they ask for: the length, the radius, the diameter, the metric screw thread specification, and then you can put in the other 2. They ask us for 6. So we give them the special ones that they ask for, and then we can put in any other one. And if we want to put in more, fine, but make sure that at least those 6 are there that they ask for, right? And the third part now is really for the paper. Um, One is here already, but I'm gonna do one just in case others want to know how the sheet must be placed in. How do we put a sheet in AutoCAD? So we have normally we have model, that's the window here that we draw in. We have layout 1 and layout 2. If we right click on either layout 1 or layout 2, right click the mouse, you will see from template. So when you click that, this window comes up with sheet sets. So we double click on sheet sets. We have some different join sheets here. We normally use the architectural metric. Double click on that. The name of the sheet comes up here, ISO A1, that's the size paper. Um, that's a join sheet. So you can click OK. It will then show up at the bottom here. If it's not showing, you will see a little arrow, arrow here that you can click on it to find the other windows if this space runs out and we're not seeing all of them, but it is down here, right? So this is the window. We can rename, this is the tab. We can rename it, right click on it. If we right click on it, we can rename it whatever the name is. I have already renamed the one which is called the removable arm assembly, right? But let's say this is the one I want to rename. Then what you would do is to right click on it, click rename, you type in the particular name and enter, so the name will come up, right? So here's a now this one here, we are now in model space. If you notice, sorry, we are now in paper space. We have the word here paper, and if we click on that, you double, if you can move from model space, it here model, to paper space. If you click on it, all right? So we are now in paper space, which means this is the actual paper. You'll see a little triangle here, which tells you are in paper space. In model space, you will be seeing this right here, right? So let's say we are in paper space. If we hold down the roller on the mouse, if we hold it down, we can pan the paper. We can move it to wherever we want it. If we roll it away, then we zoom the paper. If we roll it towards us, we are making it smaller. So it's the zooming function with the roller on the mouse, right? So what we do now when we have our sheet like this, we move, we are in the home tab. You click the layout button here and move over to rectangular. If you click rectangular, we are now able to create a little window here. You right click, pull across. Let's say you want the drawing to be here, and then you click here. So the drawing, this is showing me now everything that is in model space, everything that is on the sheet is now shown in this window. So if I only want to look at the drawing, then I will have to double click in the window, and then I can pan it to where I want it, let's say in the middle here, and then zoom it to the particular size. Remember, down here we have a scale. When we click on it, the down arrow, we can scale it to the size. Normally you're asked to draw 1:1, a particular measurement. You simply press 1:1, gives you the particular measurement, right? So here it is at that particular measurement. We can, in addition, make the window size different by clicking on this here and moving it across. We can also click this, pull it down to make the window a little bigger. Right? Another thing, another thing that we can do let's say we want to, well, uh, if we click on the paper, we are in paper space, but if we click in the window, we are in model space. And notice the edge of the object here becomes dark black. That means we are in paper space. All right, so the next thing now, we're asked to have the projection symbol here on the page as well. So we can have a separate window or we can include it in this drawing here. If we want a separate window, we can resize the drawing so that the border comes here, right? Or we can modify the symbol over here. If we move it away over here, then on this paper, we will not be able to see, right? So if we move it in model space, it will be moved here as well. So after we set our drawing to the particular scale, we should lock the window here with this little padlock icon. We lock it so our drawing cannot be shifted. Again, the scale cannot be shifted unless we click on that again to open the window. So we keep it locked after we finish setting up our scale, right? So this little area down here is automatically programmed to update. Just click on it, double click on it, and it will update. You can update the information on it. It has a part here for the scale already. So you simply click here and you can take out this and write the word full size, or you can write 1:1. That would be the scale. Once you click, well, let me write both of them. Let me both of them full size or 1:1. That's the scale. When you finish putting in your information, you apply. You apply, it will instantly change. If you notice it's changed here. The date here, you can change the date. If you double click on that, you can see the format. The format can change, and you can then put in your particular date. So today is what? Day 17, 17, 11, 20, 23, right? And if you click apply and then you come out, that your name and all of those information can be placed in here as well. So you click on the particular one, and then here you will write uh, the name. All right, and then you click OK. Right, so the information is in here now. The scale is in. The title, oh yes, the title is very important. They ask us to put the title in. So in one of these areas, we can click on this and put in the title. The title is movable arm assembly. So that's the title. So we have the title, we have the scale, and we have the projection symbol. We have our 6 measurement, we have the drawing, the front view, and the plan view all together. We put in the hidden details on the plan view, and the section is shown on the front view. So basically, this represents what the question is asking us to do. So for the most part, what would take you some time would be to draw the views for each piece, and then simply putting them together based on what is asked. So as I did with another class, I'm going to draw this nut again so that students can understand how to draw a nut or how to draw a bolt in in an exam in quick time. So for example, let me go back to the question that shows us the size of the knot that we should be drawing. Where is it? All right, so here, over here shows us the knot, and it simply says M24 hexagonal knot. That's all we are given. So in order for us to draw that, we need to know some stuff about it. So first of all, from the top here to the bottom, this measurement is 0.8 times the diameter. 0.8 times the diameter, so that's 0.8 multiplied by the diameter. In this case, the diameter is 24. So when we multiply that, we get 19.2. That's for the height here. For the width from side to side, this measurement is 1.5 times the diameter, and the diameter in this case is 24. So 1.5 times the diameter is gonna be 36. That's equal to 36. All right. So the rectangle that we're gonna be drawing is 19.2 on the side, and the length is 36. So we're going back to AutoCAD to get that rectangle. So in AutoCAD, it's line, the length, the width 19.2, and the width, we say that was what again, 36, 19.2 and 36. Right, so here we have a rectangle, 19.2 by 36. So what we can do is to find the midpoint at the top and the bottom, and then the middle of that and the middle of the other side. Or we can say what is the length here, which is 36 divided by 4. Whatever it is, we're going to divide it by 4. In this case, it was 36. 36 divided by 4 going to give us 9. So we're going to say, we're going to offset by 9. So if we offset this line here by 9, 9, 9, that gives us 4 equal parts, right? And then we're going to do another offset from the top. We're going to offset top line by 1, offset the bottom line by 1. Because we're drawing a bolt, because we're drawing a knot, then the same thing that we do at the top is the same thing that we're going to be doing at the bottom. So, same construction at the top, same construction at the bottom, because it's a knot. If it was a bolt, then the construction would only be at the top, up here, right, or one side. But since it's a knot, the construction is on both sides. All right, so let's look at now putting in the arc. Here we have the 3-point arc. We have many type of arc, but we're using the 3-point arc, which is at the top here. So we put in the arc from here up to the top, then down to here. Same thing at the bottom. All right, then we need to find the middle for this piece and the middle for this piece. So it's offset, this measures 9, so it would be 4.5. And offset this one 4.5. Then the same procedure again, from here to the top down to this part. Same procedure over here. Same procedure down here. Same procedure over here. Right, then we can remove the sections that we don't need. We can trim those out. We don't need the edge. So we trim off the edges and these section in here. Take those out. We take out this line. Take out this one, this one, this one, and this one. So this is the nut, right? Looking just like that, right? So if it's a nut, the construction is done on both sides. If it's a bolt, then the construction is on one side, and then you draw the shaft on the other side without the construction based on the length of the bolt, right? So in some cases, you might need to turn this, so you would rotate it based on the situation to fit it in the correct way. So basically, that is it, how we draw the nut and how do we assemble the joints. Now, next week or the other week, as I said before, the assembly drawing will be done in class for the students to do that particular drawing to be a part of the final exam grade, right? So it's only the multiple choice that will be done during the exam period, all right?